So this is inverse function rule. So there are times that we cannot express y in terms of x easily, such as this first example here. So if we are going to put y to the left side of the equations, it would be very time consuming because y is being squared here, so it's already quadratic. So we can use the inverse function rule. So instead of differentiating this with respect to x, we are going to differentiate this with respect to y. So just get the reciprocal of the derivative of x with respect to y later so that our answer would be the derivative of y with respect to x. So use the differentiation rules. We are just interchanging the variables x and y. So we get first the derivative of x with respect to y. So applying the power rule. So the derivative of y squared with respect to y would be 2y, no? And then minus derivative of 2y is 2 and derivative of 8 is 0. Therefore, the derivative of y with respect to x is the reciprocal of the derivative of x with respect to y. So it would be 1 over 2y minus 2. So this would be the final answer. So the second example is we have for a moment. So if we have this function, so x is equal to a polynomial raised to the power of 5. So same process, get the derivative of x with respect to y. So we have 5 times derivative no, of, this is basically u raised to 5. So we reduce no, the power by 1. So it's going to be this polynomial raised to a power of 4. And then using chain rule, multiply it with the derivative of the base or the u no, with respect to y. So we have 3y squared no, minus derivative of 2y squared is 4y. Derivative of 4y is 4. Okay, or put the 3y squared minus 4y plus 4 here. There's no need to multiply 5 to each of the terms in the trinomial. So just copy them. And then this is derivative of x with respect to y. So if we want to solve for the derivative of y with respect to x, so just get another reciprocal. Okay, so just copy everything. So this is already the final answer. So next example. So if x is 2y minus 9 all over, so this is a fraction, 7y plus 10. So using the quotient rule, okay, solve for the derivative of x with respect to y. So we have copy no, the denominator, multiply it with the derivative no, of the numerator, or derivative of the numerator is 2y. Okay, again, this is using quotient rule. I will no longer write everything, no, the step-by-step process. So just listen to what I am saying. So multiply the denominator with the derivative of the numerator. So derivative of 2y minus 9 is 2y. So if you think the discussion is too fast, then you can pause it or reduce the speed. Okay. And then followed by minus, you copy this time the numerator, then multiply it with the derivative of the denominator. So derivative of 7y plus 10 is 7 k plus 0, no, or 7. And then you square the denominator and put it in the denominator of this fraction. Okay, so simplify 7y times 2y, that's 14y squared, plus 10 times 2y, so that's 20y, minus 2y times 7, that's 14y. Then we have minus negative 9 times 7, so that's negative 63. So minus negative 63, or that's plus 63. Okay, then all over, so no need to square this, so just copy it. To combine like terms, we have the y terms, 20 and 14. So 20y minus 14, or that's 6y plus 63. And then all over the square of 7y plus 10. Take note, this is still dx over dy. So you need to get the reciprocal. So meaning we put on the numerator, the original denominator, and then that one on top will be placed here, the bottom. So this is the final answer. So this is all about inverse function. Okay, so I think there's a mistake here. Derivative of 2y minus 9 is not 2y, no, but it's only 2. Okay, 2y minus 9, so derivative is 2 and not 2y. Okay, so let me quickly erase this part. So I'll rewrite na lang everything. So ay, na-erase yung kapil. Sige, including na lang this one. So just disregard that. Okay. So again, using the quotient rule. So let me repeat. So derivative of x with respect to y is you copy the denominator, multiply it with the derivative of 2y minus 9, or that's 2, minus copy the numerator, and then multiply it with the derivative of 7y plus 10, or that's 7, and then all over the square of 7y plus 10. So 7y times 2, so that's 14y plus 20, now minus 14y, and that's plus 63. Then the square of 7y plus 10. So we have 14y minus 14y, that's 0. Then 20 plus 63, so that's 83k over the square of 7y plus 10. So again, this is still derivative of x with respect to y. So we need to get its reciprocal for us to have it as derivative of y with respect to x. So I don't we should read it as derivative of y with respect to x, and not just dy over dx, although we are writing it as dy over dx. But take note now, it's the differentiation process we are doing. Please take note of that. So the derivative of y with respect to x, therefore, is the square of 7y plus 10 and divided by 83. All right. So that would be all for the inverse function rule.